Hello, my name is Henrietta Dombrovskaya. I am a database architect at DRW Holdings in Chicago, and also I'm a local organizer of Chicago PostgreSQL user group, one of the largest Postgres user group in the Western Hemisphere, and probably the longest continuously operating. And today I will be talking about Postgres parameters. The title of my talk is Tuning Postgres parameters versus tuning your queries. And why you would like to listen to it? Well, because in this talk, I'm going to debunk one of the most popular myths about Postgres, which is that tuning parameters can solve all your performance problems. Spoiler alert, it would not. So let's see. I spoke a lot about different things in Postgres, but I never ever presented any talks about tuning parameters. Other people did, I never did. So why I'm doing it now? Well, I was tuning databases, tuning queries for all my professional life. And I never questioned what does it mean, tuning your database. So I thought I knew what it means until I started working for Enterprise DB. And then I turned out that I actually did not know what people mean when they're saying, okay, tuning your database. So that's what I found. It turned out that tuning means tuning parameters. And I am coming to the customer with expectations I'm going to help them tune their slow-running queries and stuff like this. And instead, I'm presented with the question, how we can tune our parameters. And that was like completely unexpected. So why I never ever did it before? I can tell you why. Because, okay, there are several reasons for this. So first of all, quite often, believe it or not, I was not in the position to tune parameters because I was not a DBA. I was a database developer. Quite often I was a consultant. Yeah, that was kind of beyond what I was allowed to do. So I always tuned specific processes, specific queries. And also I knew that no matter what parameters are, I can still do my job the best possible way. So it kind of never occurred to me that that is such a necessity to do something with parameters. Still, what I found recently, that people strongly believe in the magic of parameters. So what people think, that somewhere, we do not know where, but there is this sacred knowledge of, okay, so there's the magic set of parameters, and you need to apply it for your Postgres instance, and everything will start working like amazingly this very moment when you do this. So people still believe it. And it's easy, I feel it's so easy, it's so tempting to think that there is something in the world which allows you to tune your parameters and everything will be working. All right, so what I'm going to show you today, I'm going to demonstrate to you that whatever you're doing with parameters almost does not matter. I'm not saying that tuning parameters is useless. I'm just saying it's not that important that you might think. So I wanted to give this kind of talk for a while, basically since the time I learned that people believe in magic of parameters, and I always have had this situation that it's very difficult to demonstrate why parameters do not help. So why it's so difficult to demonstrate? Because when you tune the queries, you are tuning individual query execution time. And when we're tuning system, we're talking about improving the whole system for output, which is way more difficult to show, especially in a presentation. It's very difficult to model real-life workload. It is very difficult to model real-life concurrency. So building an example like this is not an easy task. However, there are well-known facts, which I knew for a very long time, and these are the facts, that tuning parameters can improve performance maybe 10%, 20%, in some cases up to 50%. Actually, recently, I was able to tune one database which was like completely over the charts, parameters were all wrong, and I improved the execution time 5 times, but that's like the personal record. However, when you tune individual queries, you can improve performance several tens of times. And it's worth noting that tuning application can improve performance up to hundreds of times. So again, those are well-known facts which are kind of like difficult to demonstrate in real life. So we will give it a try, and to demonstrate it, I will use query example, which uses PostgreSQL database. So that's QR code for the GitHub. So if you are curious, if you want to replicate all the things which I'm doing here, you can install this database on your local Mac, on your Docker, or whatever you want. And here we go. So in this PostgreSQL database, we are modeling the airline reservation system. And we have customers who are using it for purchasing tickets. And we model it also so there are people who are running reports, like running flight manifests and doing all sorts of things. So this query is a report. And let's say we just installed PostgreSQL. We did not create any extra indexes or anything. So it is what it is. So what we are doing here? We are selecting all the flights which are flying from JFK Airport to O'Hare Airport between August 8th and August 12th of 2023. And for each of these flights, we capture the flight actual departure and the number of passengers. So like normal query. So we run this query with default parameters. We're changing nothing. And what we see here, so default parameters in Postgres: shared buffers 128, work memory 4 megabytes, and that doing max parallel workers per get is 0, so no parallel workers. So the execution time is 2.5 seconds. You might say, oh, what's the big deal? This is actually a big deal because it's not gigantic database. So what you can see here, you can see that there are lots of reads, there are lots of stores. So you see that execution plan is not really perfect. So let's see how we can improve this execution by tweaking some of the parameters. So let's start from parallelism. So I think, okay, we want to add parallel execution, so we are increasing max parallel workers per gather to 2. So what we got here, yes, indeed, actually, we increased and we see that Postgres uses this parallel processing. So how does execution time change? Not significantly. It's becoming shorter, so now it's 2.1 seconds, but still it's not like drastic improvement in the execution. So let's look at other things. So let's increase work mem. So here is the thing which we are trying to improve. So we still have like 2 processes, and we still see that there are lots of sorting and things going on. So we're increasing work mem. Now we increase work mem to 500 megabytes, and the execution time is 1.8 seconds. It's improvement, right? Yes, it's improvement. We had that 2.4, now we have 1.8. But that's basically we reached the rock bottom. So now no matter how much we increase work mem, we are stuck on 1.8 seconds. And by the way, you know what? In real systems, so remember we're talking about the whole system optimization. So through output should be like something significant. So we cannot allocate 500 megabytes of memory for each process, because then we will run out of operation system memory very, very soon. So, okay, second thing. So remember we saw lots of these buffer reads. So now let's increase shared buffers. And if you're modeling it on your local Postgres, you know it requires restart, but okay, we can do it on our local Postgres, so now Docker container, all is good. So we increase shared buffers to 1 gigabyte, and we try different work mem, 4 megabyte, 100 megabytes, 500 megabyte. So execution time improves. It's like 1 second now. All right, so we had 2.4, 2.1, 1.8, it's like 1 second now. Amazing. But again, here we hit rock bottom. So no matter what we are doing, actually funny story, when you increase shared buffers even more, you'll get a little bit slower performance. But again, there are reasons for this, but let's not focus on it. So basically, we cannot make it less than 1 second, which, believe me, is pretty long time for this query. So we used all the possibilities how we can improve this query performance using parameters change. Okay, So let's try something different. Let's look at the execution plan again. If we look here closely, we can see that we have heap scan for the departures between August 8 and August 12. So let's create an index. We're creating index on actual departure. And when we create this index, now we notice that execution plan drastically changes. Now it uses index. And all of a sudden, execution time, look at this, 0.7 seconds. So we made improvement. We actually were able to decrease it for less than 1 second. Amazing. But still, can we do better? Actually, we can do better. So now we still have something else to improve in this execution plan. So we are improving this heap scan on the number of passengers. So we're building the index. We are creating index on the passenger table by booking ID. And now you can see this execution plan start to use this index. And now the execution time is 60 milliseconds. So all of a sudden, with this one correct index, we improved execution time 10 times. So we could not reach it with the parameters changes. And now guess what? What do you think will happen if now we will go back and return all our configuration parameters to default settings, which are actually very approximate, not so good. So can you guess what happened? I bet you guessed, right? The execution plan will remain the same, and the execution speed will remain the same. So now we got it back and nothing really changed. So, all right. So, does it mean that parameters are completely useless and you should not spend time even trying to improve them? No, it definitely does not mean it. So what is the role of configuration parameters? The role is to communicate the hardware characteristics to Postgres, because Postgres runs on a machine and Postgres itself, when it runs, has no idea what are the hardware characteristics it's running. So by sizing configuration parameters properly, we can help Postgres to plan execution better. Let's look at a couple of examples. Imagine that you have 16 gigabytes of RAM on your machine, and shared buffers are still default shared buffers. So the size is 128 megabytes. So what will happen? Postgres won't be able to use it. So if you would look how it uses memory, so it will still swap blocks on and off, and it will take more time. So memory will remain unused. On the other hand, if you will give Postgres the parameter shared buffers for gigabytes, you will see that execution will improve dramatically because now it can use all the memory which it already had. It just did not know. Then on the other hand, work map, which is very important. That's how much each individual session can use when it plans like joins, hash joins, sorting and stuff. So work map, we still need to make sure that it's sized this way that we never run out of the operating system memory. So we can do, work map 200 megabytes, and we can create a max connections, set up max connections to 1,000. So what will happen if all of a sudden we will actually have 1,000 connections and each of them will use 200 megabytes? We will run out of memory, and that will be also not a good idea. Or another parameter, let's look at the random page cost. So what does this parameter mean? This parameter means that how slow would be for Postgres to read data randomly, meaning using index rather than doing sequential scan. Because, we want to use indexes because they help us to select specific records which we want to read. But also it means we are not reading this sequentially, but we are reading it in random order. So when Postgres set up random page cost, for what it meant that at that time, disks were much slower than they are now. And what we are doing nowadays, the first thing we are doing by changing this random page cost from 4 to 1.1, because now we're saying that Postgres can read disks randomly very fast. In this way, we help Postgres to choose execution plan, which is better than it used to be. So this is the goal for the parameters. Parameters help us to use everything we have, but it does not help us to increase performance of specific queries. Now, last thing I wanted to mention, what we have when we're saying like application changes can actually make our applications to run really, really much faster, maybe hundreds of times. And yes, I always talk about my norm system, which allows you to completely rewrite the way application talks to the database, but it does not have to be something drastic. So, for example, oftentimes I see in the applications people use like this approximate condition, and do we really need it? Or you are fine, you can use equality. And you know what? When you start using equality, all of a sudden you can use indices and execution time drastically improved. Or like, for example, very often when people want to select the time, which is within one date, instead of using created date between this and that, they are using truncate created at to current date, and then what happens? The index on created at cannot be used, and queries are running way, way slower than they should be. Other examples are committing each record after insert, or the other example on the other side of the spectrum, not committing until the batch ends. So all of these changes, they seem to be really minor, but at the end of the day, those are the ones which really makes applications run really fast. So that's what I wanted to share with you. So again, moral of the story, we are not abandoning Postgres parameters changes, but when we tune queries, we are getting much better performance gains. Thank you so much.